Hi and welcome back to another Blazor build. Today we're creating an accessible modal dialog framework that works with any interactive mode. I originally built this framework for Blazor .NET Core 3 and up until last week it was still running in my .NET 8 applications. The original version included a focus trap to keep keyboard users from navigating out of the modal dialog. However, it didn't remove elements beneath the dialog from the accessibility tree. And in fairness, most implementations don't. In practice, that means screen reader users with all their shortcut keys could still access elements behind the modal despite the focus trap. I've been keeping an eye on the native dialog element for a while now, and with recent browser improvements I decided it was finally time to make the switch. The key advantage is that dialog comes with built-in focus traps and effectively mimics the inert attribute, hiding everything behind the dialog from assistive technologies by default. The trade-off is that I had to add a small amount of JavaScript, just enough to programmatically open and close the dialog and override the default escape key behavior. This matters because if the dialog is being used as a form with unsaved changes, you'll probably want to warn the user about losing these changes instead of just having the dialog close, which is the default behavior. The framework is comprised of a component for displaying the modals and a service for orchestration. If your project uses the interactive global mode, i.e. a single interactive type, it's straightforward. You can place one instance of the modal dialog container component in the roots component and you're done. If you're using interactive per page, combining all three interactivity modes, placement depends on the behavior that you want. However, a simple approach is just to include the component only on the pages that serve as a root for any dialogues. I say root as a modal can open another modal and so on. These other modals do not need the component. I've added guidance in the comments within the roots component to help with this. In this video I walk you through using the framework so you can understand its capabilities. In a second video we'll then dive into the code behind the framework. You'll see how it was built, giving you the confidence to either build your own from scratch or use mine as a reference. Okay, let's begin. The solution is a Blazor web app using the interactive auto, server and WebAssembly per page template. Alongside it there's a Razor class library project that contains the modal dialog framework. Debugging in WebAssembly Razor pages seems to be currently broken in .NET 9, so I opted to use .NET 8, but the component is good for both. Visually the framework is quite minimal. It mainly handles the backdrop and provides a frame for hosting your components, so there isn't much CSS involved. For the demo I built a couple of components that get loaded into this frame, and I've added custom CSS specifically for these. I've created 3 pages, each housing the modal dialog container component and named accordingly to their interactivity mode. Again, see the comments in the roots component for additional information about component placement. All 3 pages use identical code and markup. Under each page heading you'll see the location where the code is running, server or client, depending on the interactivity mode. Each page has a button that calls show dialog, which is set to load a sum form component. This component can also raise a modal dialog if the user tries to cancel the form with unsaved changes. Let's look at the markup for the ServerModal page. To communicate with dialogues, we use the modal dialog service that gets injected into the page as seen at the top of the page. Within the code block on line 40, we create a SomePersonData object that we will provide to the component shown in the dialog window via a modal dialog parameters object. This component has a parameter named SomePersonData of the type SomePersonData. The framework works with regular Blazor components, so any parameters that the component accepts can be passed in via a Modal Dialog Parameters object when calling showDialog. Additionally, we can pass a Modal Dialog Options object to control where the dialog appears, top, left, center, bottom, etc., as well as to specify a maximum width. The window that holds your component will grow and shrink accordingly, as it has both min and max heights and widths set. On line 47, the showDialog method is called with its type param set to the component to be loaded. This method returns a modal dialog result when the dialog is eventually closed. The result object tells us which button closed the dialog and if it was cancelled, as well as containing a data property for returning custom data if the dialog was not cancelled. In this example, if the dialog isn't cancelled, we'll get back a SomePersonView object through the data property. Let's run the app and walk through the different open, close and cancel actions. I'm just clearing any cached WASM files to ensure a clean start. We're starting on the ServerModal page. As the text indicates, this page is running on the server and the dialog is set to appear at the top center of the screen. As I haven't specified a maximum width, by default that'll be 70% of the screen width, with a maximum of 100% minus 2 rem, with a minimum width of 330 pixels. Let's click the Show Dialog button. Since there are no changes yet, the Save Changes button is styled to look disabled. It still receives focus, so it remains accessible to screen readers, but it won't do anything until there are imaginary changes to be saved. At this point, we can either press the Escape key or click the Cancel button to close the dialog. Both actions trigger the same method, so it doesn't matter which one we use. Let's go with the Escape key first. The dialog closes and focus is returned to the Show Dialog button. Let's open the dialog again, but this time we'll tick the checkbox to indicate that changes have been made. Now if we try to cancel via the Escape key or the Cancel button, another dialog appears. This one is positioned to appear bottom left corner and has a maximum width of 50%. If we were to click the No button, which is the cancel action for the confirmation dialog, we would be returned to our form. If we were to click the Yes button, then the confirmation dialog would close, with a result indicating to the form that the user wants to exit without saving it, so it too would close. Let's press the Escape key, which behaves the same as the No button. Now focus is returned to the form's Cancel button. Let's click it again and this time choose the Yes button to confirm the close. We're now back on the ServerModal page with a message indicating that the operation was cancelled. Let's reopen the form, tick the checkbox, followed by clicking the Save Changes button. This time we receive a SomePersonView object as the result from the dialog. So far we've only been on the home page and the ServerModal page. That means there's currently a WebSocket connection open. Let's now go to the AutoModal page. Since a WebSocket is still active, it will continue running on the server. Keep an eye on the cache storage panel to the right. You'll notice that the WASM files are now starting to be downloaded and then cached. Now let's move to the Client Modal page. Pre-rendering is on, so you may spot the location saying server before changing to client on the first visit to this page. During our time on the Client Modal page, the WebSocket should be closed, meaning that the Auto page will now run on the client WebAssembly. Let's see what its location says. If we now go to the ServerModal page, a WebSocket will reopen, and if we return to the Auto Modal page, it will detect the active connection and once again choose to run on the server. While all of this is technically very cool, if you're building an app where maintaining per user state is important, I'd strongly recommend not using mixed interactivity modes unless absolutely necessary. Your life will be much easier if you simply choose a Blazor template that uses global interactivity, either server or WebAssembly, and stick with it throughout your app. Before we wrap up part 1, let's take a quick look at the components used for the demo, as these are what you would build for displaying within the framework container. What I like to do is to create a couple of general purpose components for dialogues, like a confirmation dialog and an error dialog. These can be styled appropriately and can accept parameters for things like the icons and the text, making them reusable across the entire application. As you can see, my confirmation dialog is just a regular Blazor component, and as such can include whatever parameters are required. The parameter values can then be provided to the component via the dialog service showModal method. After I have created all of my general purpose dialog components, I then create additional components for dialogs as required, such as pop-up forms. That's it for part 1. At the time of this recording, I hadn't completed part 2 yet, so it may or may not be available depending on when you're watching this. However, all of the source code is freely available and already on GitHub. The link is in the video description below. Part 2 should be available in the next few days. If you enjoyed the content or found the code useful, please hit the like button, as it helps a lot and encourages me to keep making more content. Thanks for watching. Until next time, bye for now.